This video is brought to you by us, RealPARS. Join the top 1% of PLC programmers. Learn from the world's best so you can join their rank. Head on over to realpars.com and start learning now. In this video, we will discuss industrial robots and what they are, and the mechanical and electrical parts of a robot. We will cover robotic applications, simulation software, and manufacturers of industrial robots later. Robots are electromechanical devices that can be used for many tasks. These tasks can be as simple as moving a box from one conveyor to another. Robots are excellent at doing very specific, repeatable tasks. However, they can also be used for more complex tasks, such as building automobiles on an assembly line. Whatever the job may be, robots can be used to save labor costs, reduce unergonomic conditions, and improve efficiency. Robots come in many shapes and sizes. The type of robot is defined by how many axes are used. For each axis, there is at least one servo motor that moves to support that part of the robot. For more information on servo motors, refer to the "What is a servo motor and how it works" video. You can find the link to this video in the description. Another name for a servo on a 6-axis robot is a joint. Depending on which robot manufacturer you are using, they have similar nomenclature for this servo. For the simplicity of this video, I will use the term joint to reference each axis. The reason the axes on a 6-axis robot are called a joint is that most 6-axis robots look like a robotic human arm. And like the human arm, a 6-axis robot has joints. Each of these joints is made of servo motors with gears and belts to mechanically drive the robot. To keep each of these joints lubricated, special robot grease is used, which is an important part of keeping a robot running. Assuming proper maintenance is being performed on the robot, some of its moves can be repeatable to a couple of tenths of a millimeter. The robot's repeatability is one of the advantages of a 6-axis robot. 6-axis robots come in many different shapes and sizes. Some robots are small enough to place microchips on circuit boards, while others can lift heavy objects like vehicles. Each robot is sized to the desired application. A few factors in choosing a robot are reach, payload, and speed. The reach of the robot is how far the robot needs to extend in order to reach all the objects in the cell. Payload is how much weight a robot can carry to accomplish a task. Most robot manufacturers use kilograms to measure the payload. Speed is how fast the robot will move while lifting its payload. The bigger the robot, the slower it can travel. Each 6-axis robot has mechanical brakes, a necessary part to prevent movement when the servos are not engaged. Each robot has mechanical hard stops that prevent the robot from moving too far in on some axes. We will now discuss the electrical components of the robot. Like we discussed earlier in this video, 6-axis robots use servo motors. Those servo motors use electricity to move the joints of a 6-axis robot. Each servo is selected depending on the size of the robot. The servo at the base of the robot, usually called Joint 1, is the largest servo motor. This motor must be able to turn the weight of the robot as well as the weight of the payload. The smallest servo motor is usually called Joint 6 and is usually at the end of the robot. Joint 6 only needs to move the payload in a specific motion, a motion much like moving your wrist. Joints 2 to 5 can use 1 to 2 servos, depending on the payload. Most medium to small robots use only one servo per joint. Another part of the 6-axis robot is the controller. A 6-axis robot controller is an electrical cabinet that houses all the main electrical components that are needed to drive the servo motors for each axis. These cabinets have a few different main components. They have a disconnect switch that allows for lockout-tagout functions. The line voltages can vary, but are typically within 208 to 600 volts AC. They also have many printed circuit boards or PCBs, which will vary between manufacturers. One of the PCBs controls the e-stop functions of the robot. Some 6-axis controllers have fuses to prevent the board from being damaged in the event of a miswire of the e-stop circuit. There is also a servo amplifier in the 6-axis robot controller. The servo amplifier is used to convert line voltage into a voltage that can be used by the servos. Each robot controller has some type of CPU, which is used to make movement calculations. Some 6-axis robot controllers are expandable to add auxiliary axes if a 7th axis is needed. These cabinets also can house I/O for the interface of peripheral equipment. Another part of the electrical of a 6-axis robot is the Graphical User Interface, or GUI. Some GUIs are electrically tied to the controller, while some use a computer instead. The GUI tied to the controller is a handheld screen with keys on it that are used when programming the robot. When moving a 6-axis robot, there's a safety switch that has 3 positions: 1 off, 2 held, and 3 squeezed. This is a safety feature to control the robot when it is being moved manually. When the handheld screen safety switches are engaged in position 2, this will release the brakes and enable the servo controller to drive the motors. There is also an e-stop button on the handheld GUI, which can force the robot to shut down if a human is dangerously close to a robot while it is running. Another important part of a 6-axis robot's electrical system is the servo encoder backup batteries. These batteries will keep the servo encoder counts when the power is removed from the robot controller. These batteries should be periodically changed, or the encoders will need to be reset. Each manufacturer has a process to set the servo motor counts. Failure to change the batteries according to the manufacturer's instructions can result in unexpected downtime. Most 6-axis robots have cabling running through them. These cables are for all servo motors and various sensors that are needed to run the robot. Depending on the manufacturer, some of the inputs and outputs, or I/Os, are run internally. There are also external I/O options that are used. The I/O of a robot depends on the application. Whether internal or external I/O is used, the I/O can drive actuators or see the status of sensors that are mounted on the robot. In summary, we covered the characteristics of a 6-axis robot, the mechanical parts of a 6-axis robot, and the electrical parts of a 6-axis robot. Later, we will cover robotic applications, simulation software, and manufacturers of industrial robots. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.